Hello. This is the first video about a project I've been working on, and the project is to make a desk lamp that's shaped like a rocket engine. Rocket engines having this big flared nozzle, kind of like desk lamps have this big flared reflector. And if you're asking yourself why somebody would want a desk lamp that looks like a rocket engine, then I don't think this video is for you. You should probably go and watch something else. So this model I have here is a model somebody else did, and it's of the Merlin 1D rocket engine. This is the engine that SpaceX uses in their Falcon 9 and Falcon Heavy rockets. And I thought it was a good choice for what I wanted to do. Now, when I start off, I have this problem, and this model here is a mesh model. And you can see, if you look closely up in here, you'll see there's some holes. You'll see that, it's not actually a solid model in that sense. But there's actually a bigger problem. My tool of choice is Fusion 360. And while Fusion 360 can display meshes, as it's doing here, it's not really designed to model meshes. So what I need to do is take this and create a real Fusion 360 model out of it. Now, if you look at my timeline down here, you can see there are a whole bunch of steps, and I'm not going to walk you through all of them. I'll just take you through a few steps, and then we'll just kind of jump to the end and see what I ended up with. So the first problem I have is I need to create this big nozzle shape, kind of from starting down here, down at the end of the bell, all the way up. This is the combustion chamber in the middle, and this in the real engine would be probably a feed pipe. There'd be an injector up here for the propellants. So I need to model that shape. So what I'm going to do, I'll show you what I did. So we have a sketch here, and essentially what I'm doing is I'm modeling. Let me turn off the mesh so it's a little clearer. You can see I'm modeling a very thin nozzle here, and I'm just building out of arcs and straight lines all the various components I have here. All the various different sections of the nozzle. So I started with that sketch, and then I'll turn on what I did. And this is the first body. So now take that sketch, revolve it around the Z-axis, and I end up with something that's pretty good. And that was pretty quick. And well, unfortunately, a bunch of the operations after that are not quite so quick. There's a lot of complexity in what the engine is. And I'll just kind of scroll along here. So here we reach this point. Off to the right, we have what's called a gas generator. You can think of this as a separate engine that burns a separate little rocket engine. So it burns propellants in this part, puts them out in the nozzle, and it's also that it can drive a turbine, and the turbines are what actually pump the propellants through into the combustion chamber. So not all rocket engines work like this, but this kind of rocket engine does. Look a little farther. What did we get? Okay, so that was a little subtle. One of the problems I have is I need to be able to 3D print that. And that means that I can't have lots of big steps. I need to have smooth transitions. So if we look really closely, right here, you see that? This used to be vertical, came down and went out, and now it has a 45 degree. And the 45 degree there, I'm confident I can print on my printer. And we go on some more. And now we get to a different body here. So, back up. This is kind of where the engine ended up fully. And at this point, it's made up of 4 different parts so that I can 3D print it. There's this nozzle part. Let me show them one at a time. There's this nozzle part here. There's the gas generator part. Both of those are hollow, not surprisingly. Then we have what I call the top, not a very technical name. And this has 2 sections, and both the nozzle part and the gas generator fit inside. So if I turn those off, pan up, you can see there are little recesses here. So the nozzle fits up into there and the gas generator fits up into there. And maybe if it wasn't clear before that this thing here is actually not solid, this is actually a thin pipe. And it will be important later in the project that this actually be a thin pipe. Won't tell you why now. So anyway, end up with that. And then finally there's this one little piece that goes on top here. That's there for a specific reason as well, which I will also talk about later on in the project. So anyway, that's the basic engine design, and I printed this out. I'll probably show you what that looks like after this session. So I printed this out and took a couple sets of iterations, and I came up with a design that's pretty good. Then the next problem, it's like, how do you attach this to anything? The problem being that this has to attach to some sort of lamp arm to support it. And how am I going to do that? And what I essentially did was I bought a desk lamp and took it apart and reverse engineered how it connected the reflector to the arm. And it turned out to be mostly about this kind of curved little part. I'll show that in the pictures afterwards. And what I essentially did at that point was I took the design of the desk lamp and I created what I'm calling the hanger. And let me turn off the other parts. So this is what the hanger looks like. So we have this round section here, or cylindrical section here. This is what the nozzle fits into, and you can see there's kind of a little step there. So part of the nozzle, the lower part of the nozzle fits here, and then the upper part of the nozzle that's a little bigger fits in here. And then here we have this little hole, and what's going to happen is the existing part of the desk lamp is going to come through the back, fit through that hole. So it will be sticking out to the side here, so we can connect it. And then we will assemble everything else together, and then we will have a somewhat solid, not sure how I'm going to attach these on yet, but a somewhat solid connection in between the desk lamp, which comes off to the right, and the nozzle here. So that's the first step that I did. And just to compare, so this is the designed engine, and that's the mesh body that we started with. And you notice, hey, there are a few places, many places where it's almost identical, and a bunch of places where it isn't. Most obviously, this is a gas injection, what would be called fluid cooling in the rocket biz, set of piping, and that I just elected not to model at all. Mostly I didn't model it because it looked like it would be pretty hard to print on the 3D printer. I could probably get this part here to print, the vertical, but this part here seemed challenging. So I omitted it. The other thing you can notice here is this pipe, as it comes around, in my engine, it's flat. In the real engine, it kind of droops down, and then it has this kind of nozzle-ish sort of thing. And that was also because I wanted to be able to 3D print it. So I think this has to be 3D printed in that orientation. And that orientation means I can actually print this whole pipe pretty easily just sitting flat on the bed. If it went up a little bit, I would have had to use support, and I don't like what support does. So I decided to change the design. So anyway, that's our rocket engine, that's our hangar, and that's where the project is so far. I'll show you, switch over to real time and actually show you some pictures of the parts that I actually made. We'll show you some video of the parts I actually made. Here we are looking at the actual rocket printed pieces, and these two pieces here are the first two that I printed. This was trying to print it all at once. Well, it didn't make sense from a 3D printing perspective, and it's a little too tall for my printer. So I printed these two pieces. So this is obviously the nozzle piece. This has the gas generator part here, and then the top of the nozzle, and then the connecting pipes. This was kind of the proof of concept. It has a few problems. The first one is that these are like the same size, so they don't actually nest together. That's problematic. You can't get inside of the gas generator. This is all one piece. And this connecting pipe across here is actually not a pipe, it's a rod. But this was enough. You could kind of, you know, set it like that and pretend that it was what you wanted. So, went back, did some more redesign, and these are the current pieces. Old nozzle, new nozzle. The new nozzle's a little bit bigger. And then I have the other parts. So, as you saw on the design, here's the gas generator, here's the nozzle, and here's what I call the top piece. And this actually does what you want. You can take the nozzle, and that's pretty nice. It's a slip fit, and because you have the different layers, it doesn't just fall apart. So that made me happy. And then similarly, the gas generator just nests inside. I'm not sure this is the final version. One of the problems with, if we can look really closely, probably can't, but inside of this, this pipe is way thinner. It's probably a millimeter thick, and that makes it pretty flexy, and I'm kind of worried that it's gonna be damaged and break over time. So I might reprint that, redesign that, and print that. So it's basic design for that. And then, as I said, we had to move on to figure out how to do the clamp. And I obviously wasn't very prepared. This is the donor desk lamp, so it's an oval lamp. And the way this connected, little piece goes in here, little piece like that goes in here, and then that can go up or down. Okay, that's great. And then that was riveted on to the actual lamp piece. So I need to do something that will work with that, and rather than trying to redesign this and 3D print it, I decided just to use this piece. So that will be, this piece will be the transition between the desk lamp world and the rocket world. So what I needed was the piece that went here, and I showed you in the model there's kind of this clamp that hooks around. Now, no, I didn't show you this. So the way this worked on the real lamp was that piece goes through there. You can see it's kind of inside, and then this clamped around the cylindrical piece. And my original idea was I was just going to take this and kind of, you know, melt it and get it to go around here. And I decided that's kind of a stupid idea. You can do better than that. So, first test is this kind of ugly 3D printed piece. And basically this was a test to see if I could build a piece that was kind of correct for holding that piece here. And it more or less worked. More or less worked, wasn't perfect. I changed the dimensions of some, played around a little bit, but it more or less worked. And you can see it, obviously it goes through. And then that finally evolved into this piece. And I was actually very pleased. It was printed in this orientation, and the hole is actually pretty circular, which is pretty darn good because getting the upper part, the filaments are almost hanging there. And that's really a challenging thing to do. So I was pretty happy with my printer. This top part here, you can see, how do I show this? You see on the inside there's kind of a top and a bottom. And this part here had to kind of be painted in the, printed in the air. I didn't want to use support, and it came out okay. I had to clean up a little bit with a Dremel. And what do we get? We get, actually, after a little cleanup, we get a really nice fit there. So now that we have this, go back to our model. This slides over, top part comes on, and there we have our rocket motor desk lamp with attachment fitting. Now this kind of turns kind of easily. When I printed the hanger part, I deliberately printed it a little oversized because I did a little test print, and it kind of didn't want to fit very well. I haven't decided. I may just, deal with that and not worry about it, or I may reprint it to get it closer to the actual size because it would fit a little better. So that's where we are so far. In the future, I'll be talking about electronics and what the lamp is and all of that sort of fun. And I think that's going to be the more exciting part of the project. But first step, we have a physical lamp-shaped thing. Thanks for watching. See you on the next one.